Okay, so in lesson 3, we are going to be looking at the relationship of multiplication and addition. We've looked at the relationship between addition and subtraction, and multiplication and division. Now we're going to look at multiplication and addition. So the first example asks us to write two different expressions that can be depicted by the Tate diagram shown. One expression should include addition, while the other should include multiplication. So if we're doing addition, we can just simply take the number in each tape diagram and add them together. So 3 plus 3 plus 3 would be our expression. And remember, an expression does not have an equal sign or an answer, so we would just leave it like that. Now, this is just repeated addition. So in repeated addition, you can just take the number you're repeatedly multiplying and multiply it by the number of times you're repeatedly adding it. So 1, 2, 3 times. So this can be seen as 3 plus 3 plus 3, or 3 times 3. In the next one, I have 1, 2, 3, 4, 5, 6, 7, 8, plus another 8. So again, to show it with multiplication, I can take the number I'm repeatedly adding and multiply it by the number of times I'm adding it. So 1, 2. So 8 plus 8, or 8 times 2. And this one can also be written as 2 times 8. That commutative property says it's okay to switch the order around. Okay, so that's just a little reminder of how multiplication and addition are related. So now it's asking us to try these. It wants us to write the addition expression as a multiplication expression. Write the multiplication expression as an addition expression. So we're just kind of doing the opposite of what it's given to us, and that is a multiplication sign. That's why I'm darkening it. So as we said, with repeated addition, you can take the number that you are repeatedly multiplying and then multiply it by the number of times, the number you're repeatedly adding. And you can then multiply it times the number of times you see that number. So there's 2 4s, so 4 times 2. This can also be written as 2 times 4, because again, commutative property says that doesn't matter. If I have 2 times 5, that means I have 2 5s being added together, but it can also mean I have 5 2s being added together. Okay, so either one of these will give me the answer that the 2 times 5 would. So they're both going to give me the same answer. So now comes a challenge. Write an equivalent expression to demonstrate the relationship of multiplication and addition here. So in this case, you'll see there are two different numbers being represented. So what we would do here is we would write it as a multiplication and addition problem. So in this one, 7 plus 7, I'm doing 2 times 7. And I'm also adding to that 8 times 3. Because of the order of operations, I don't really need the parentheses here, but I'm just doing it to separate them out. And of course, you can do this in a variety of ways as well. I can flip the 2 and the 7, I can flip the 8 and the 3, and I can do it in just a bunch of different ways. This is just one way to show it. Okay, so now that we've seen it with numbers, we're also going to start looking at variables, which we mentioned yesterday, that a variable is a letter used to represent a number. There are some other terms that we're going to be using throughout the unit that I'm going to introduce to you now. The first one is coefficient, and this is the number being multiplied by a variable, and sometimes a variable can be a coefficient as well. So we'll see what that looks like. A term is a single number or variable, or numbers and variables being multiplied together in a math problem. So if we look at an example, 3f plus 4, 3 is a coefficient because it's a number being multiplied by a variable. F is the variable because it is a letter used to represent a number. And then 3f and 4 are the terms. These are two things that are being added together. So two terms in this problem. We can show the relationship between multiplication and addition using variables as well. Okay, so write each addition expression as a multiplication expression. So if I have two h's being multiplied together, that means I'd be writing down the number and then, or the variable in this case, and how many there are. So 2 times h. With variables, the way that we write it is we put the number first and then directly next to it goes the variable. So this means 2 times h. You can write it with the dot. I would not write it with the x because it looks like the letter X and that can be confusing. I would really like you to get into the habit of just putting the number first and then the variable. So now h is our variable, 2 is going to be our coefficient because that's the number being multiplied by the variable. If we look at the next one, we have 1, 2, 3, 4, 5 z's being added together, so this would be 5z. It now wants us to write each multiplication expression as an addition expression. So 3j means 3 j's added together. So j plus j plus j. 4y means 4 y's added together. So that would be y plus y plus y plus y. So in the try these, we're writing the addition expression as a multiplication expression, and then write the multiplication expression as an addition expression. So with repeated addition, I'm going to count how many there are. 1, 2, 3, 4, 5, 6. And the letter that's being repeated is G. So 6 times G, or 6G. 2V means that I'm repeatedly adding the letter V 2 times. So V plus V. For a challenge, what we're doing is we are going to be showing multiple letters in here. So here I have 2 Z's being added together, so that's 2Z plus 1, 2, 3 Y's. So that would be 3Y.